An important part in improving the quality of patient care is to collect process data over time, plot it, and then analyze the variation. Analyzing this variation using the appropriate graph, or what we like to call making meaning from evidence, can help you build understanding when starting an improvement or patient safety effort, as well as help measure any changes that may take place. Let's chat a bit about variation. Variation will always exist within any process. The key is to determine if the variation you are seeing in the data is normal, or if there are some unusual events taking place which are impacting the process's normal flow. To better understand this, let's look at an example: your work commute. You decide to collect data for a month on the amount of time it takes you to get to work. Looking at your data, you see that it generally takes you about the same amount of time each day, and any variation that occurs is mainly caused by normal factors, such as traffic, the route, coffee shops, etc. This normal or random variation is better known as common cause variation and is considered to be in control. But looking at your data again, you notice that there was one instance where it took you almost twice as long to get to work. Thinking back, you remember it was because of a spring snowstorm, which made the road conditions treacherous and therefore significantly impacted your commute time. Events like these within a process do not occur under normal conditions and are considered to be non-random events. This is often called special cause variation, and at these times the process is considered to be out of control. Run charts and control charts are good tools to graphically represent variation within a process. Analyzing this variation helps identify times of special interest or concern, and identifies opportunities for improvement. A run chart is a fundamental tool used in quality improvement to graphically display how a process performs over time. It is also the first step in creating a control chart. The x-axis displays the chronological unit used, such as time, date, or year, and the y-axis displays a measure of interest, such as percentage or count. The data points are plotted on the graph and then connected with a line. A center line is often drawn as a first step to analyze the data in the graph. For a run chart, this center line is the median of the data, or the point at which 50% of the data points fall either above or below this value. Run charts are best used when you have a smaller data set or are beginning to examine a process and you don't yet have a lot of data collected. Turning this run chart into a control chart allows for deeper analysis and monitoring of the variation. For control charts, the measure of interest is still plotted on the y-axis and is graphed against a time period or unit on the x-axis. However, the center line for a control chart is represented by the average or mean instead of the median. And statistically calculated boundaries or control limits are added. There is an upper control limit noted as UCL and a lower control limit or LCL. These help to determine if a process is in control or if there is any special cause variation occurring. Control charts are used as a primary tool within AHS to track or monitor a process, program, or service. When using a control chart, common cause variation is seen when the data points fall within the control limits. Therefore, the process is considered to be in control. But if any data points fall outside the upper or lower control limits, or forms an abnormal pattern, this indicates special cause variation, and the process is considered to be out of control. If special cause variation is identified, avoid overreacting. Instead, examine your data and pinpoint the unusual condition to understand what occurred. As it relates to process improvement, examining these different types of variations within a process helps to guide what improvements need to be made. But be careful. An in-control process may be stable and predictable, but it does not mean everything is okay. A process can be completely in control but have huge variation, or worse, not meet the patient expectation or organizational goals. Improvement efforts focus on improving common cause variation to make the process more consistent and perform closer to the organizational target and patient expectation. Efforts will often focus on those factors that occur within normal conditions. As mentioned earlier, the control limits are derived statistically from the data. Conventionally, they are set at 3 standard deviations, or 3 sigma, above or below the center line. Additional zones can also be identified between these control limits to allow for more in-depth analysis. Zones A, B, and C represent 3, 2, or 1 standard deviation from the mean. These zones are often identified by dashed lines on the graph. A set of rules we refer to as the control chart rules use these zones to identify special cause variation and to determine if a process is out of control. The rules identify 5 abnormal patterns. The control chart rules state special cause variation exists if there is 1 point above the upper control limit or 1 point below the lower control limit. This suggests something was different at this point. Or where 8 or more points appear above or below the center line. This indicates a shift, suggesting something happened in the process during that particular period of time that was not present at other times. If 6 or more points increase or decrease in a row, a trend has occurred and something changed that continuously impacted the process. Or if 2 out of 3 points are above or below 2 sigma, or jump 2 zones, special cause variation has occurred, and this could be an early warning sign of a process shift. And lastly, Rule 5. If 15 or more points fall only within Zone C, this hugging of the average reflects less variation than typically expected, and could be an indicator that a process has improved or there is an issue with the measuring system. Here is a control chart you may encounter in your role. What can you conclude? Would you say this process is in control or out of control? Is there any special cause variation? Did you say the process for the most part is in control, but there are 2 points of special cause variation? 1, where a data point falls below the lower control limit, and 2, a shift occurred where 8 points are above the center line? Your next step would be to pinpoint and understand what changed during these times of special cause variation, and use this data to inform the next steps. A control chart is a good tool to use when you want to evaluate a process and identify opportunities for improvement or investigation. Control charts can be used in the Build Understanding step when using the AIW method for improvement, as well as in the Act to Improve step to observe any improvements that may have taken place. In AHS, leaders are able to access data for a specific area or project through a number of sources, such as RLS, FACT, Statit, and Tableau. If you require assistance using these or require additional support on ways to collect data for your project, AHS Clinical Quality Metrics is a great resource to support the design and development of measures and strategies to help clinical teams obtain and use data to improve quality. Also, Process Improvement and Clinical Quality Improvement collaborates with staff, medical staff, and patients to improve clinical processes provincially and within each zone. All of these groups can be found on Insight. Thank you, and good luck making meaning from evidence.